that's it, I think. I give the stage is yours, Fabio. Sorry. After the meeting, we will go to. I think I don't know if we go to take a beer or to a Chinese restaurant, but we have a couple of ideas. If you want to join us, just raise your hand if you think that you will join after this meetup. To have an idea of. Okay, let's see. Not very much. Okay, thank you all, and Fabio, please come.
Thank you. Oh. Good evening. So today we will talk about some tips and tricks to use to improve our usage of Pandas. In many pipelines that I saw in my career, the usage of Pandas is something like that. A very slow pandas that eat a lot of junk food, that can move from his bed. I hope that at the end of this talk, you will have some more useful tools to have your pandas in your pipeline look something like more fast, more gymnastic, more athletic. I know what are you thinking. Why we need a talk about pandas? We have a lot of new library, polars, Dask, and so on. Well, first of all, Panda have a rich API built in years of coding from Pandas developer, a big community, a big documentation. And I believe that if you have a big pipeline, changing some little line of code, using some little trick can save you a lot of time and a lot of money instead of changing the whole pipeline to a different library, such as Polar, that is very expensive, changing an entire pipeline with a new library. So at least we have to maintain Pandas for a while because it's one of the most used. Was one of the most used. Let's make an example. So imagine that you have been employed by New York City Mayor Office and as a machine learning engineer, and the first job that give you is to improve the efficiency of a Pandas pipeline. This pipeline read a pretty huge data set of 2.5 gigabytes, and that contain taxi trip in New York City. So this is the data set. Every row is a taxi trip. We have a lot of information, the pickup date time, the drop-off date time, the trip distance. We have some information about the place where the client was picked up, some payment information, latitude and longitude, and so on. And this is the pipeline. It's a very short pipeline. We have three main steps. Import and filtering is a pretty simple function. I know that doesn't respect the single responsibility principle, but basically read the CSV containing our data, make some date type conversion, and filter the data about rush hour. So because the pipeline calculate the average speed in rush hour. So here we need to filter our data by rush hour. So from 7 to 10 a.m. and for 4 to 7 p.m. The second step, basically, it's very simple, calculate the average speed in miles per hour for every row, for every trips in our dataset. Use a simple function that calculate the trip duration, convert the trip distance in miles, because we are in New York City and we don't know unit metrics. and calculate the actual average speed dividing the trip distance by the trip duration per hour. The last step of this pipeline is basically the mean of the average speed calculated before for every county in New York. So, importing data and filtering, calculating the average speed in miles per hour, and calculating the average speed for every borough of New York City. And we measure the speed, the computational time of this pipeline, and with this data set, take 51.4 seconds. That, in computer science term, is like a geological era for a task like that. So our Pandas is still sleeping very well. So let's do something to improve the performance of this pipeline. And the first line that every pipeline have is read the CSV, is read something, could be read JSON, read CSV. So it's a very important part of our pipeline. And this read CSV takes 17.2 seconds. So maybe can we do something to improve this? But it's not only a matter of computational time, but it's also a matter of memory usage. So our dataset on the disk weighs 6.7 gigabytes, and now after importing in memory using rich CSV, weight like 3 times the original, 2 times at least the original value. Can we do something? Yes, we can remove the useless column. We can save some space with this. It is very simple. But we can do something more about the memory usage. We can see that the trip distance has the right type, right? Is a float 64. That is quite correct for a trip distance. But all the other columns are object. The point is that rich CSV imported this column as an object, as a string, recognized that it's a string, and Pandas doesn't have a proper data structure to contain string, an efficient data structure to contain strings. So the only thing that can do is storing it in Python objects that are quite expensive, both in terms of computational usage and in terms of memory usage. But Pandas have some datetime data type. And so we can tell to read CSV to import the two datetime columns, so pick up datetime and drop off datetime to a data time, to a date time, sorry. And this make us save 1.5 gigabytes. Also, the county is saved in an object, and it's correct because it's a string, right? But it's a very special string, because here we can use a domain knowledge, some domain knowledge that we have about the borough column, and we know that this column contains a lot of unique value, a lot of repetition of the same string. So we can use a cool data type of Pandas that is categories. Basically, what Panda does using category is saving the string, the unique value of the string in a separate memory area. So here we have only 87 unique string, and index every of the string with a number. It's a sort of dictionary. Now we can save in our data set that has so many rows, much more than 87. We can save just in an integer that is a more efficient data type. So using this little trick, we save another like 800 megabytes. Now our data frame weight only 290 megabytes. A quite huge improvement. We will talk later about Apache Arrow if you are curious, But let's say for now that read CSV can use many different engines for read CSV. And PyArrow is a very efficient way to read, has a very efficient engine to read CSV, and is much more efficient, is 15 times more efficient than the default Python engine. But in reality, CSV is not, in general, a very good way of storing data. If you think about it a little bit, you have to read the file. You have to split the string in by underscore. You have split every line by comma. You have to guess which data type the column have. It's very expensive to read a CSV file. Nowadays, there are many open source formats for big data. One of these is Parquet. Parquet is an efficient open source columnar format for storing data in disk, and is very efficient because use a lot of compression technique to save data in less space. Is very performative in terms of computation over this data because columnar storage is very efficient, and take some information about the data, some metadata. For example, could save the type of the column, and so this give to Parquet an advantage in terms of speed, reading speed. Pandas fully support Parquet. In fact, I try to convert our data set in Parquet, and I try to reread it and take like no time, like 157 milliseconds, that compared to 1 second and something of before is like instant. So it's very cool. It's a very cool format. So we have our pipeline. We make import and filtering, in particular read CSV, more efficient. I take the CSV because it's the original data that we have from our client. And so we halved the time of our pipeline. Now take from 51.4 seconds to 27.2 seconds. So half of the time. What we can do? We can do something more. Maybe yes. Remember the second step of this function that calculates the average speed for every row of our taxi trip dataset. The problem here is that we are using an apply function, and under the hood, Pandas apply use Python code, use a Python loop. Python loop are very slow operation, and we don't want this when we have big data, a lot of data. What we can do, we can remove the apply, and we can call the same function, the same exact function, but passing directly the full series. What is happening here is that Pandas is smart enough to pass the series, to pass the data to the NumPy low-level code. And the NumPy low-level code makes the operation leveraging the parallelization that almost every modern CPU has. So notice that we didn't change the function because they were simple operation inside the function, and Pandas understand that this operation could be vectorizing because this technique is called vectorization. And this gives us a huge improvement from second to millisecond, from 23 seconds to 37 milliseconds. So ban a loop from like your life. So again, the pipeline now have this function without the loop. We take some advantages, and now we have another huge improvement from 27 seconds to 2.76 seconds. But we can do better again, and I want to introduce you a new kid in town, to improve this performance. The new kid in town is Apache Arrow. Apache Arrow is an open source columnar, again, in-memory data format, in-memory data format that is very efficient, is built with efficiency in mind, and for big data in particular. And have a lot of data type, missing data support, and that Panda right now with the actual backend, NumPy backend, doesn't, because for every data type, Pandas need to build a strategy for that data type. Instead, Apache Arrow have just one strategy for missing data value. Have improved performance, high performance in input and output, and we saw earlier in the read CSV. And Apache Arrow is now another backend that you can use when working with Pandas. But the main, I believe, the main advantages that Apache Arrow give is also interoperability. So basically, a lot of other libraries use Apache Arrow, like Polars, like many other big data tools. So let's say, with an example, that we have a client that then give us a SAS file containing some data about airline, in this case, and ask us, after some analysis, a report using LaTeX. So what we want to do is using Polars, because we know that Polars is very efficient for the calculation that we want to do, because they have a cool API, lazy evaluation, and so on. But doesn't have read SAS and to LaTeX API. Can't read the SAS and can't write to LaTeX, but Pandas can. So since we have the same underlining backend, what we can do is call from Pandas and to Pandas function that, instead of copying the data from one format to another, can use the same exact in-memory data, with avoiding a lot of copying that cause slowing down pipeline a lot. So say that, going back to our pipeline, I tried to use the type backend parameters in rich CSV that tell Pandas to use the data type backend to import the data. In fact, import the same exactly data, but with PyArrow data type. And yeah, we halved the time, just 1.32 seconds. We have 2 seconds and something before. This is summing up our improvement from original code that was 51.4 seconds to the PyArrow backend, with all, of course, improvement in the middle, of 1.32 seconds. Now, PyArrow is not the default Pandas backend from Pandas 2.0, but we can use it because many API aren't supported. And but I think that this will be the future of Pandas, and developers are working hard to extend the Apache Arrow functionality to all the API. Okay, we are very happy. We improved our pipeline, and we send the result of some calculation to the New York City mayor. And okay, job done. But after some time, the mayor replied with an angry email saying that some data are wrong, like there are some counting that have zero average speed. There are, but most importantly, the first one is like 33 miles per hour in mean, but is, I don't know, an empty county. There is some error. The point is that this is a very simple pipeline, but in big data pipeline, detecting and debugging error in the middle of the pipeline is very hard. And sometimes this error propagate through the pipeline because are just logical error on the calculation or on the format of the data. And this error propagate through all the pipeline, and we can see them until the end or until some weeks because maybe we don't see them. But we have some tool to check this error. One of these is Pandera. Pandera is a very powerful library that fully supports pandas, and with this tool we can define a schema for our data frame. Also, we can check the types of the column, we can check some properties of the column, we can make some statistical validation of our data, and it's very useful. Let's make another example. For example, for our pipeline, I want to define a schema. I want to say that I want to be sure that trip distance have a type float, and all the value in this column is greater than 0. Or for example, the borrow is a string, and every value should contain some character. This is a very simple regex expression, and the mean value for the length is 1. I can validate the schema using the method from data frame schema class, and this is very useful for pipeline, and I use a lot, using some decorator that check the output or check the input. Now this example is just check the output. So every time the function is called, Pandera check input and output of the data. And the cool thing is that Pandera raise an actual error. So here is saying that there is some problem with string length, and tell us in which row this error was found, and show us the failure case that, of course, in this case are all empty string, because the problem was that the length was less than 1. So wrapping up, we say that using proper data types save us a lot of memory. That if we know something about the type of data that we have, we can leverage category to save other memory. CSV is not very good for data storing, in particular for big data. It's better to use some other format, such as Parquet. Avoid the loop in your code because slow down the computation, and try to use vectorization, in particular for parallel task. That arrow is probably the future of Pandas, and we will see something more in the future by developer of Pandas, and that you can save a ton of ADH and error using some validation tool for your data pipeline, such as Pandera. But before saying goodbye, let's say one more thing. How many of you know this warning? Yes. And every time we don't know what to do. But there is a reason because Panda raised this warning. The reason is that experienced Panda user hardly understand if some operation in Pandas is returning a view or a copy of your data. For example, here we have a data frame with some data, and we are getting an item, a column, assigning it to a view variable, and writing some value in the first row of the column. We can think that we are modifying, looking at this code, the first idea is that you are modifying the first row of view, and the F is unchanged. This is not true, because the get item in this case is returning a view, not a copy of the data. So we are editing the view and also the data frame, the original data frame. This is something that you don't want happen. So when sometimes Panda understand that there is some strange operation and warn the developer that maybe the results are not what you are expecting, that maybe you are modifying something that you don't want to modify, and raise this copy warning error. From Pandas 2.0, we can use the mode copy on write. We can set this option to true, and this option basically make every operation that write on some variable, the rule is that for every write, the write must be done on a copy of the data. So this makes setting with copy warning disappear. It's from the performance point of view, this could slow down a little bit the code, but avoid a lot of random copy then we pass through the data frame, because sometimes they are simply don't need it. So we can remove all the dot copy that randomly put around our pipeline and use this copy on write that copy the data only when we need to copy the data. So I hope that you get some value from this discussion, and maybe try to use some tips and tricks to improve your Panda usage. And as a last slide and nego slide, I'm Fabio Lipreri, a machine learning engineer at Extreme. And get in touch, feel free to ask and discuss on LinkedIn or now or in front of a beer.
Okay, any question for Fabio?
Hi. Hi. First of all, thanks for the talk. I have a question. I actually have two questions. Both are pretty small, and both probably comes from my ignorance. But about Parquet, I don't know too much about it. But is it like some kind of binary representation of? Okay, I've seen a couple of Stack Overflow posts saying that, oh, Pickle's better because it's usually like 3 times faster or whatever. I don't really understand why such things happen. I'm not. Have you ever used like both and compared the performance of them? Is one over like better over the other or whatever? If you have an opinion on it. And the second one is, I'm not exactly sure also for the NumPy backend either, but how is the performance of PyArrow on high dimensional data, like rather than, okay, so Arrow must be super good with a ginormous amounts of rows per data frame, but I'm not exactly sure what happens if the number of columns also becomes, I don't know, hundreds of thousands or something like that, which is technically possible, although it's not something that we touch in everyday life. So I was just curious about those two.
So for the first question, yeah, I know Pickle is another binary format. I think I don't know very well how Pickle, which operation perform Pickle on the data before storing, but Parquet is very efficient, and I think that Pickle don't do this because store makes a lot of compression on the data and make a lot of compression algorithm to reduce the size on the disk. So for example, if you have a lot of data, you can also save some money on cloud. And also is a columnar date format, and not only columnar, but save also group also row for column. So it's very efficient in retrieving the right data in the right time. I don't know Pickle very well from the detail of how work under the hood, so I don't know if it's more efficient or less, but Parquet is very, very efficient, and is used, for example, in Spark, in a lot of other data frames. For the second question, is a good question. And I don't know, because Apache Arrow is something new on Pandas, and in general, I never tried some comparison between like cardinality data compared to a lot of row. So I don't know. We can maybe make some deeper search about it. Good question, by the way. Thank you for the question.
In your experiments about the performance, did you try by chance to compare just Pandas 1 versus Pandas 2, and is there some free gain in terms of performance?
With Apache Arrow backend, yes, due to Apache Arrow in Pandas 2.0. Apache Arrow was also from Pandas 1.4, if I remember well. They start to introduce some, for example, data type using Apache Arrow. So using Apache Arrow for sure. Sometimes because the many API is not ported yet, so sometimes the pandas have to fall back on NumPy. In general, there are a lot of improvement, but not. I mean, from my experiment without Apache Arrow, not significant. Like using Apache Arrow, yes, but due Apache Arrow, due the new backend, not for Pandas. There are some news like copy on write, some different usage of data type, but yeah, we will see. Yes.
So Marco Gorelli in the Intervista Passionista, he said that it's just the beginning for PyArrow, and he wants to chill down, that there is still some work to do. Can you dive us a little bit on your decision tree, whether to start a new project with PyArrow, or when you think it's not mature yet, and so it's a no-brainer to use it or not to use it?
Yeah, maybe because Pandas is very used, but also used in like everyday life to make some little data analytics. I think that is the case if you don't have a lot of data or some strange situation or some strange performance issues, maybe is good to stay on the old NumPy. Apache Arrow, for what I see, Apache Arrow is very efficient with string, because as I said, Pandas doesn't support string fully and have to store it in PyObject. But if you have a lot of operation on string, using PyArrow string, the operation on this string are very efficient, very efficient. So maybe, yeah, it's better for string. If you have a lot of string right now, I will use. Or some performance issues like a lot of data, a big pipeline, I will use Apache Arrow. Try to use Apache Arrow for what I can. Yeah, it's just the beginning, as you say. So not all API are ported. So.
Thank you, Fabio. Well, actually, it's not a question, it's an answer for the pickle against Palke debate. What pickle does is that it serializes the whole Python object. So what you're storing is not the data, it's the Pandas data frame. So you have an harder time compressing it, which means more space on the disk. You cannot use all the amenities that Parquet provides, that is like scanning the disk and not taking everything into memory. And most critically, you have a binary representation that is unsecure. Someone can put malicious code in there and get it like executed once you load the pickle, and that brings the information about the object, so the version of the library that you use to serialize the data. So if you serialize the data frame with Pandas 1, then Pandas 2 comes out and it takes breaking changes, you're done. So always use Parquet, I think it's the conclusion. Or don't use pickle.
Thank you. Yeah, I was not sure about pickle, but yeah.
That's it. Oh, actually, I had a question. Did you use Midjourney for the pandas?
I painted my.
Oh,
I used my.
yeah. Nice. Give me the prompt after.
Yeah.
Okay, thank you very much. So just a couple of minutes to switch the PC, and we will have the next guest, Pietro Peterlungo, and